Saxon Math 7-6, Lesson 111. This is a fun lesson. I like it a lot. It's about an easy enough topic. It's about division. And we're going to apply it to some story situations. Okay? I will tell you ahead of time that there are not a lot of hard and fast rules about how to work these problems. You kind of have to logic them out. Okay? And I'll tell you what I mean by that as we work along. Let's try the first one. Let's just dive in. 100 students are to be assigned to 3 classrooms. How many students should be in each class so that the numbers are as balanced as possible? Okay, we immediately see it's a division problem, right? We have to take this group and we have to divide it up into 3 classrooms. So let's do that. 100 divided by 3. 3 goes into 1, not at all. 3 goes into 10, 3 times. 3 times 3 is 9. I subtract. I bring down 10. Oh, it's the same number we had last time. So 3 times 3, 9, minus 10 minus 9 is 1. Okay? Now, we could bring down. We know that you can put in a decimal and bring down. But we're trying to calculate how many students go into each room. So it's not really going to help to go into decimals because we cannot chop our students up into decimal pieces. I mean, we could, but then they're not students, they're dead bodies. And that's a whole different problem and we don't want to go there. So what we realize is that we have a remainder of 1. So we have to think logically about what that means. That means that when we're dividing our students up, we're not going to have the same number of students in every classroom. We're going to have 33 in one room, and then we're going to have 33 in another room. And then the third room, we're going to have to add that one more kid. So we'll put 34 in the third room. They're circular classrooms, let's pretend. So this is our answer, that the way we divide them up that's the most even is 33, 33, and 34. Does that make sense? Okay? We can't just write remainder of 1 and we can't just create decimal numbers because that doesn't work in our story. Example 2. I think I just wiggled my page. Movie tickets cost $4. $4 even. Jim has $15. How many tickets can he buy? Okay, it's a division problem, right? We're trying to see how many times we can get 4 tickets to go into $15. So he takes 15, we divide it by 4. I don't need to worry about the decimals. 4 times 4 is 16, but that's too big. So it's 4 times 3. Okay, now we have a remainder. So we have to stop and think about what it represents in this story, right? This one was different. This was students in a room. Tickets, can you go up, if the tickets cost $4, which really dates this problem and shows us just how old, because what are tickets now, like 12? Can you, if tickets cost $4, could you go up to the window and say, I want to buy $3 worth of a ticket? No, they would say, sorry, you're out of luck. So all he can buy, Jim can buy 3 tickets. That's it. He'll have $3 left over, maybe for popcorn. But that's as many tickets as he can buy. It doesn't matter that there's a remainder. He can't use that to do anything more at the ticket window. See what I mean? You just have to logic them out and it's kind of fun. 15 children need a ride to the fair. Oh. Each car can transport 4 children. 4 kids in a car. How many cars would be needed to transport 15 kids? So how many cars for 15 kids? You don't necessarily have to write down these facts on your paper, and I'm just kind of writing them randomly. I write them down because you can't see the book, so I can't really point at that very well. But in your work, you don't have to. You can just look in the book. Okay, so we've got these 15 kids. We can fit 4 in a car. So we want to take our 15 kids and divide them up among the 4 cars. Look, it's the same numbers as we had last time. So we see 4 goes into 15 3 times. That's 12. We get 3 left over. Okay. So what we can say is, okay, we need 3 cars that are full. That would take care of 12 kids, but we still have these 3 kids left over. So we're going to need 4 cars. We're going to need 3 cars that will be full. And then these 3 leftover kids tell us we need 1 more car. And this one won't be full, but we need 4 cars in all. Right? So this one we have to round up. Here we had to round down because they won't give you a movie ticket unless you have the full amount of money. And here we had to round up because these kids get to go to the fair even though there aren't enough to fill in the car. I would say that one of them should invite a friend to make it full, but that's not the point of the problem. That's a different issue. Okay, one more. Four workers were paid a total of $15 for cleaning a yard. If the workers divide 15, it's the total amount that's paid to them. If the workers divide this money equally, how much money would each worker receive? Okay, so again, we take the $15 they were paid and we divide it up among the 4 of them. 4 into 15, well, we've established that goes 3 times. That's 12. We subtract 3. This is just like the kids, right? And the ticket. Now, here's what's different about this one. We stop and think, can we go into decimals or do we need to stop right here? We can go into decimals this time because it's money. And we know that money, we've got pennies, nickels, dimes, and quarters, so it doesn't have to be just in dollars. So we can now put in a 0 and start bringing down zeros, right? We'll put a decimal in our answer. How many times does 4 go into 30? 7 times. 28. Okay, we can take it to 2 decimal places because money goes to 2 decimal places. We subtract, we bring down another 0, and look, it's going to work out fine. So those 4 workers can split that $15 among the 4 of them equally and get $3.75 each. In this particular context, it works to use decimal places because money is decimal places. We're not chopping up children or telling people they have to stay home from the fair. We are giving people some quarters as well as their singles. All right, so that illustrates the charm of these problems as well as the headache. You have to think about each problem specifically and logic out what makes the most sense. The math part isn't the hard part, it's the making sense of your answer. Lesson 111. We're done. Goodbye.